Hello, ladies and gentlemen. My name is Borelle and I will be talking today about using machine learning to recognize graph and functions. I am interested about this topic because nowadays, most of technology are using machine learning and I wanted to understand it and apply it to feel like mathematical graph and functions. Have you ever wondered how face recognition works? No? Okay. Face recognition uses the principle of neural network. This project will explain in a few minutes how we use neural network to identify graph and functions. Machine learning has been applied in many domains, has ranged from acoustics, processing, image recognitions, and so on. Artificial intelligence, which is also used in this project, is a way of making computer things intelligently and the similar way as human. This project type using machine learning to recognize graph and functions is focused on how to distinguish image. We use Python and machine learning packages such as Keras and TensorFlow. Neural network used here is right on Python and can recognize triangular region based on point sample. In figure 1, we train a neuron to distinguish the indicated half space using the blue and the red point as our training set. In figure 2, we see a representation of a single neuron along with its mathematical definition. In figure 3, we train a multi-layer neural net to distinguish the indicated triangular region using the blue and the red point as training data. In figure 4, we see a representation of that multi-layer neural net. The method used here is based on biological neurons. Mathematically, our neurons take input, multiply them by the weights, and normalize the output to be between 0 and 1, passing through the sigmoid functions. As figure 5 shows, we train our neural network to recognize line and parabola. After we have created a training set of 10,000 to 16,000 computer-generated image, our neural network was able to distinguish accurately image of line and parabola with a high percentage of accuracy. To minimize the loss at the end of the sigmoid functions, we have this formula of the gradient descent algorithm from multivariable calculus, which we name L here. The other part of this project, we build a neural network to identify mathematical functions. To realize it, we use a combination of computer-rendered and hand-drawn image of functions. In addition to that, a regression functionalities has been applied to create a computer application which can see an image of the function and guess what type of function is it. A sample of those functions is shown in black color on figure 6, 8, and 10. And beside them, we put an output generated by our Python program after applying the regression. How do we obtain those outputs? We use a large amount of computer and draw image that we call original image in our case on figure 6, 8, and 10 that we consider as input into our Python program. This Python program trains itself with those inputs, and after training, he applying a regression function, and the output are generated as the best fit of picture that you have entered as input. And he superimpose it for us to see the difference between the picture that you have entered, the black one, and the one he draw, the red one. Notably, the more input, the better our system is trained. We have also included a little part of our Python code. This one is the function that superimpose pictures. The training process used is based on pictorial representation of a neural with his formula that you can see on picture 16. How it works? We just have a system in our case, a program that will take a large number of inputs, picture in our case, and train itself and generate the best output, regress picture in our case. The picture 17A and B shows how we store our input. We store them in a folder, and each of those folders contains a lot of image that you can see on picture 17B. To conclude, we have learned so much in this project, particularly Python language, because at the beginning, I was not fluent in Python. Also, the big takeoff is the process of recognizing graph and function based on the hand-drawn pictures. we faced a lot of difficulty during this project about the version of the software that we were using, Python. And it's important to notice that the efficiency of our program is not at the top. It takes around 5 minutes to train our neural network, depending of what kind of computer you are using. And our next objective is to make it better. Thank you for listening. We are open for question and suggestion.